So you've just finished a homework assignment, and I don't have a new assignment to hand to you yet. So I guess that means that you have a little bit of relaxation time, or actually we're going to be working an in-class example. At the end of class today we'll have an example that I'll introduce, and it's kind of complicated. We may not finish it in class, and so you can continue thinking about that, but it won't necessarily be something that I collect for credit. All right, so the entirety of today's class is focusing on a three-letter word, for. So, if we're going to spend the whole class period on that, it gives you a sense for how important and powerful it is. It really allows us to do some new things that we haven't been able to in the past. It allows us to repeat calculations. All right, so thus far, what we've been doing is writing scripts or putting things into the command line and executing them a single time. So in other words, we define an array and do calculations to an array, and it was over. Or in the case of, remember, tick-tock, sometimes it wasn't over like as quick as snapping your fingers. Sometimes it took a while, but it was linear. Things started on line 1 and went down through however long your script was. Maybe it graphed it, but whatever the case was, it was a single operation. But of course, MATLAB and computers in general allow you to do things multiple times and execute calculations in loops. And so the for command is one of the ways that we can define a loop in MATLAB, and it's one of the biggest strengths is repetitive calculations that you wouldn't necessarily want to do yourself. Because remember, I've introduced this idea before that there are cases where you can definitely do the calculations in Excel or even on your calculator more quickly than you can type them in to MATLAB, especially when it comes to trying to figure out where the parentheses would go and the order of operations. Sometimes it can be a little bit confusing in MATLAB. And so MATLAB isn't always the ideal tool for every situation. But where MATLAB becomes particularly helpful is when you would have to calculate things over and over and over again, and you'd rather automate that process instead of calculating it yourself so many times. All right, so the pair of commands that we're going to use for that is for, which in the mind of MATLAB starts to trigger a loop scenario, and then it's paired with end. And that's how you tell MATLAB that the loop has concluded. All right, now the syntax in a for end pair is you have to tell it how many times to do it. And the way that MATLAB is set up for defining is that there's a counter value, and that's here called the index. And so you're going to tell it, do something 10 times, then the way it's going to keep track of how it should do things 10 times is each time it goes through the loop, it's going to add 1 to that counter. And so here the counter is called the index. And so that can just be any variable. We can say, and commonly in today's examples, we're going to be assigning the variable k as our index variable. And then here, for where it says start, you typically put in a starting variable or a starting value. So maybe you could say start at 1, stop would be 10, and then here in the middle where it says step, that is the stepping distance between your beginning and your end. And so you can say step is 1, so if you go from 1 to 10, then it would do 1 calculation, 2 calculation, all the way until the counter reaches 10, and then it would terminate. Or if you want to make things a little bit confusing, you could have non-integer values for your stepping distance. You could make it 0.5. And so if you said start at 1, stop at 10, and the step is 0.5, then it would do the calculation 20 times. We have to be careful with that, though, is because this will keep executing repeatedly until it reaches the index counter. And so if you don't define a proper ending value, then your program can hang. Now here is a kind of a flow chart that shows how the logic behind the for end operates. And so the variable, which here we're calling index, that's a counter variable. So it begins at a starting number. may be 1. And the MATLAB is going to ask itself, is the index value that I'm at right now equal to the stopping index? And if the answer is yes, then it's not going to execute the calculation anymore and it immediately goes to end. But if it hasn't yet reached the stopping point, then it will execute all these statements that are embedded within the for end pairing. And then after that, automatically built in is the idea of adding 1 to the index. And then it goes through that cycle again. All right, so again, the stepping value, I think what makes the most sense is for it to be 1. And in fact, 1 is the default assumption, so you don't even have to put a stepping distance of 1. If you just put in a start and a stop, then MATLAB can operate from that. But it can be any real value, positive or negative. So you could do a stepping distance of 2 or 3 or whatever, and then it would count in those increments. There can also be a problem related to using non-integer numbers, and that is if you used kind of an odd number, like if you wanted your stepping distance to be 0.143, then because of round-off issues, it may execute an unexpected number of times. So it may be doing 1 fewer time than you had intended or 1 extra time than you had intended because of the way that it's adding a non-integer round-off value. If you're using a positive value, then the index terminates when it's greater than the stopping. But if it's negative, then it's when it's less than stop. So in other words, you have to think about what direction your number set is going, if it's adding numbers constantly or if the numbers are decreasing in value constantly because of a negative step value. Now, once start is equal to stop, then it will only execute it once. If the start and the stop are the same, then essentially the cycle will only repeat 1 time. And the index itself, the variable that you use for the counter, can be adjusted inside of the loop, but that's not advisable because it automatically is going to be adjusting the counter within the for end. And then another tip that is something to keep in mind is it can be confusing for other people who are interpreting your program if you used I or J as index variables, because quite commonly in programming those variables are used for other things. And so in today's class, for instance, we're going to use the variable K as the variable for our index, and just reserve I and J for other things. All right, so here's the first calculation that we're going to work on automating. And I'm sure that formulas like this are already familiar to you. The way to interpret this is that we're going to start with K is equal to 1. We're going to square the K value, and then we're going to add that to K equals 2 squared. Add that to K equals 3 squared, and so on. So all the way from K is 1 until 5, we want to first of all square the K value and then sum them all together. And so if you're going to evaluate that by hand or by using your calculator, then the interpretation is 1 squared plus 2 squared plus 3 squared, and so on. And the answer to that is 55. All right, so it's easy to do by hand if there's only 5 terms. But if you get too far beyond 5 terms, then it may be an argument in favor of trying to automate this process. Now, the way that we want to automate this is with the following for end statement. So you'll notice the first thing that we're doing is we're setting x equal to 0. And the reason why is we're just sort of defining the variable that we're going to be doing the calculations with and making sure that the starting point is already equal to 0, because later on we're going to be adding things to it, and we want to make sure that it's kind of like an empty variable to start with. You'll notice here that the index is assigned the variable k, and then our starting point is 1 and the stopping point is 5. And since we didn't specify a stepping distance, MATLAB is going to automatically assume the stepping distance is 1. So it's going to execute this 5 times. So the variable set to 0, the loop will execute 5 times in this case, and after we run the script, we should get the last variable for x is going to be equal to 55. And so think about the before and after of each time this script runs. At the beginning, the first time through, when k equals 1, x was 0, which was our starting value. But then it's going to do this operation. It's going to be 0 plus 1 squared. And so then the x value at the end of the first loop will be 1. And it remembers that when it heads into the second loop. And so now k is 2. So x is 1, so it's going to be 1 plus k, which is 2, squared. So that's going to be 1 plus 4, which at the end of it gives us 5. Okay, so I heard some clicking. If you haven't already, let's try and see what's happening in this. Now you can type it into the command window. This will operate in the command window. Just to demonstrate that, let me CLC, which is clear the screen, clear, which is clear my variables, x equals 0 for k is from 1 to 5, and now it's just pausing. You notice that it didn't give me these brackets because it knows that it's sort of in the middle of an operation that hasn't ended yet. Okay, so for that, x equals x plus k squared, and then end. And it executes it all at once. Now, more usually what we'll do, rather than typing those sorts of things into the command window, is we'll create a script. So doing the same thing in the script, CLC to clear the screen, clear to make sure the variables are empty, and then x is equal to 0 to make sure we have that variable defined and that it's equal to 0 for k is from 1 to 5. And now, a nice thing about typing it into the script editor is it kind of indents automatically, usually. Occasionally it'll slip up, but you'll notice that this screen over here, the indicator on the left is reminding me that I haven't finished the for statement yet. So it's telling me I'm still working with an open loop. And that can be handy as well, that visual reminder. All right, so it's telling me this is going to be inside of the loop. X is equal to x plus k squared. All right? Now, I could do more things inside of the loop, but I'm finished, and so I type in end. It automatically indents that the correct way. I'll save this. Uh-oh. Oh, yeah. Good catch. Thank you for noticing that. The plus and the equals is on the same key on the keyboard, so I need to be careful. Otherwise, we're going to get errors. All right, so save. Let me put that into a temporary folder. Oh, poor Microsoft OneDrive. Nobody loves it. All right, so I've saved it. Let me run this. All right, so it does the same thing. Here now x is defined as 55, which is the end result of the calculation. We knew from before, when we looked at it this way, x should be equal to 55. And so that's what we get here as well. Usually repetition is boring, right? Hearing the same thing over and over again is boring. But computers don't mind repetition, and so it's good for us. We liberate ourselves from repetition by just knowing a few little commands. We can have the computer take over the stuff that we don't want to do. Any questions about this first one? Okay. By the way, it's not a bad idea to save even these in-class example scripts because it has an illustration how to use syntax that it seems obvious now, but next week maybe you've forgotten exactly what the formatting is supposed to look like. And so having a functioning script, an example that you kind of remember, will hopefully jostle that in your memory. So I'd encourage you to save your examples. All right, this one is all right, so we had k as the final index value, k equals 5, and our answer was 55. And if you want to make it so that it automatically clears the k counter, just so that it's available next time, you can put in at the end of this script, you could say clear k and save that. And then when we run it here, the only thing that'll be left is the x. And so run that, does the calculations, and k isn't shown as a variable anymore. So that is an option that's available to us. And why would you maybe need that? That would be useful if you had multiple loops inside of a program, and if you wanted to reuse the value of k to be the index in a subsequent loop later on. All right, so that one was kind of easy. This one is a little more tricky. How to calculate this. So I'd like you to try to write a script that calculates the sum multiplied by -12 and then all of it taken to the 1/2 power. And let me give you a couple of hints that I think may be helpful. Let's talk this through before you get started on the programming. All right, so for this calculation, what's going to be our index variable? What should we call it? Let's just call it k like we did before. That's fine. What is going to need to be the starting and the stopping value when we define k? It should go from 1 to 10, because it says here the summation is from 1 to 10. So inside of your script, you're going to need to have as the the syntax for, if we look at this one, you're going to say, first of all, x equals 0 to make sure that you're creating the variable and it is set to 0. And then instead of k equals 1 to 5, on this next example, we're going to do k equals 1 to 10. All right, now sometimes the tricky part is figuring out how to write this with the appropriate number of parentheses and divided bys and so on. So let me pause for a moment and give you a chance to do this in pseudocode. Now this is something I actually remember when I was in your shoes. I had a programming instructor when I was an undergraduate student who insisted that before we started typing on the computer, we should kind of like write an outline on paper that was like the logic of our program. It didn't have to be exactly what we were going to ultimately type, but it was like the main ideas, like the bones of what we were going to program. And so what I'd like you to write down is, how do you translate what's inside of the summation into a calculation? So in other words, you're going to do the -12 and the 1/2 power outside of the loop. The only thing that you're doing in the loop is the calculations that's shown to the right of the summation sign, and then it automatically is going to be adding it all together. All right, I'm going to pause the recording and give you a few minutes to see if you can do the calculation using a script. Now the answer that you're looking for is 3.133, so if you don't get that, if you get a different number, chances are good that you've just got parentheses issues, that the order of operations aren't doing it right. I was playing around with the parentheses earlier, and I was getting 4 for my answer, 4 point something. So let me pause the recording and give you some time to work on this. Of course, it's fine to collaborate with your classmates as you do that. All right, so let's break down the pieces of this script. First of all, CLC and clear are meant to clear what's showing in the command window and clear all of the variables that are defined in the workspace. So making sure that everything we want to use isn't a leftover variable definition from a previous script. All right, x equals 0 is we're defining the variable that we're going to use for our calculations. And then the for statement is what we pair with end, and inside of that is the loop. And so for k is the index or the counter that's going from 1 to 10. And then the calculation here is it's going to be x, so the previous value of x, because remember we're doing a summation. So when we go through this each time, this first x that's here means the previous value that you had for x plus all of the new stuff for the next part of the summation. And so the first time through, x will be 0, and it will only be doing -1 to the power of 1 divided by 1 squared. And then the next time through, it's going to remember the result of that and assign that to x, and then add on the next values for k equals 2. All the way through 10. When it hits 10, then it will end, clear the counter k, and then here at the last part, you can see outside of the for end pair is where we're doing the square root of -12 times x. And why are we doing that at the end? It's because we don't want to repeat that over and over again. All we want to repeat all over and over again are the stuff that's to the right of the summation. We want to multiply the sum of all those things by -12 just a single time. And then we want to take the square root just one time. So that's why it's outside of the loop. All right. So if I run that, well, we've already got the variable assigned. I run it, it'll stay that number. Now remember that you can save these scripts and save and copy and paste. Making a program is a little bit like a Frankenstein thing. You know, you take a piece of this and you combine it with a piece of that, and you make a monster. Your program can be a monster. You just take little bits, and then it can become very sophisticated with just a few combinations. All right, so here's another one. We can do loops to calculate element by element computations. So let's try this one out. Let's take a look. First of all, before we start typing it in, let's understand what it's doing. All right, so a equals and then a string of numbers here. This is defining an array. And then n equals length of a. What this is going to do, as you can tell because there's some nice comments, it's going to set n equal to however many terms there are. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So it's going to count up how many terms are there in that matrix, and it's going to set n equal to however many terms there are, just the number. It's not going to be the sum of all of them. It's just how many terms there are. Now x, remember that before our previous loop, we wanted to define the variable that we're doing the calculations with. And so this is the same thing, but if we're doing calculations with an array, then we have to create a new array for the calculations to go into. So that's what this third line is doing, is it's creating some array that is going to have nothing but zeros in it. It's just going to be empty, so that then that array can be filled in inside of the for n statement. So we didn't have to count them all ourselves. We have the computer count. And then inside of the for n statement, you'll notice it's doing calculations on an element by element basis. And so x of element k is saying, don't square the entire matrix all at once. What we're going to do is we're going to use this to square each term individually. And so we want it to be 5 times 5, and 17 times 17, and -3 times -3. In other words, this script is going to take A, the input matrix, and create a new matrix X that has for each one of those terms the square of the input term from A. All right, so let's try that. Put that in here. So it's kind of nice that we created this variable n, because it automatically adjusts how many cycles it needs to do and how big our resulting matrix should be based on how many terms there are in A. So if we wanted, we could add additional terms to A, and we wouldn't have to change the n or the size of the matrix, because that's all happening automatically through the count. This length term here. So let's run this, and what we're trying to go for is each term should be squared. All right, so if I get into X, double click on that in the workspace, then it takes me here to show me it's 25, 289, 9. So that is the square of A. So A was 5, 17, -3, and X is just each term has been squared. It's still 1 row and 13 columns, but each term has been multiplied by itself. Now that's nothing new, because we were able to do that using the dot operator, the element by element multiplications. So that's not really the strength of MATLAB, but we can use MATLAB to do different operations to each term inside of a matrix. So if you combine it with if statements, then you can have it, for instance, with the same input matrix A. What if we wanted it to square any one of these terms that was positive, but then take it to the third power if it's negative? And so the result of that is it's going to preserve the sign of the negative numbers. So you'll notice that this modified script, what it's doing is it's saying, okay, we've got our input matrix A. We're creating our variable n based on how many terms there are in A. And then X is the empty matrix where all the answers are going to be stored. And so we create that empty matrix so that the answers can be put in them. Then we have our for n statement, which is a repeat. And inside of the repeat, we have it analyze if the numbers are greater than or equal to 0, or if they are not greater than or equal to 0, then that means that by process of elimination they must be negative. So the else is just if it isn't this, then do the else. And inside of the if is square the term, and inside of the else is cube the term. So let's make a new, let me close the editor here, make a new script. And rather than having to type everything over again, let's copy the first 5 lines of the third example. So you just Control C on the keyboard, and I'm going to paste that over here, Control V. So that saves me from having to type in matrix A again. That's handy. All right, but what we do want to have is a slightly different structure inside of the loop. So as k goes from 1 to n, now here's the if. If the kth element of matrix A is greater than or equal to 0, then it's going to say for that kth element of matrix X, which is where we're putting all of the answers, it should be A of k. So that means the element that we're working on, square it. Okay, else, otherwise, then for that element, we're going to cube it. And then we end the if-then statement, because we can't have more than, a single if-then. It could be many different conditionals there. And we're also needing to end the loop, and then we clear our counter just in case we are going to use it somewhere else later. I'm going to save that.
Are you going to cube the else statement?
Oh yeah, I squared it, didn't I? Thanks for noticing that. That was the whole point, was to cube it. And I also want to suppress the echo, so I forgot to put in those semicolons. There we go. I think that'll be better. Let me save that. Example 4. What I'd suggest as maybe a useful thing for you to do is to, with these files that you're saving, and I assume that you probably have examples from previous classes as well. If you don't, this is only the 6th lecture. It would take you maybe like an hour or 2 hours to go through all of the previous lectures and create M files for the examples that we worked. Make little notes. Print them out. You can print these and make little notes to yourself on what's happening. I did that for one of our examples. I said what different components of the program are doing, just because it can be handy as a reference. And on the final exam, you're going to have some programming to do. Next week, we'll talk about the notes that you're going to be allowed to bring in for the final exam. But as a study tool, I think it'd be really useful for you to have all of these example scripts just maybe in a notebook or a folder so that you can use those to study and prepare for the final test. Okay, so we haven't executed this. What we want to do is we want it to cube the negative terms, and any of the positive terms should just be squared. So if it works correctly, then x should be 25 for the first term. For the third term, though, it should be negative 3 times negative 3, which is going to be 9, but then times negative 3 again, which will be negative 27. So let's run that and see. Okay, it ran it. Now let's open up the x matrix to see what it did. All right, 25, it squared that one, and this one it cubed. So it preserves the negative sign for the negative terms by cubing it, but then the other ones have been squared. All right. Any questions about why things are a certain way inside of this script? I always struggle with this. Like, it makes sense when I see it, but then when you have to synthesize something new, that's when it gets tricky, is when I just say, all right, do this calculation then. And so that's why I say it's really helpful to have examples, is you just basically are copying the syntax from previous examples that you've worked and program that way. All right, so here's the example I said that we're going to spend some time working on today, and in fact, this is complicated enough that we may not be able to finish it all today, and that's all right. But before you get started on this, let's talk through a couple of things that are going to need to be in this script. Basically, this is particle motion, and a particle is moving at different speeds during a different amount of time. And so from 0 to 10, you could know its distance by 0.5x squared, where x, t, that's the letter t. So 0.5 t squared, so t is the time in seconds, but then from time 10 until right before time 20, it's following a different movement, and then from 20 to 30, a third. Okay, so we want to make a script that says, what is this particle doing over time? Because eventually what we'd like to do is create a graph that looks like this. And so during those first 10 seconds, this is what the particle is doing, and then it's going from 10 to 20 like this, and then from 20 to 30, it's doing that. So there's 3 distinct phases. Now, there's going to be several things built into this script because, for one thing, we're ending with a graph. And so all of the previous experience that you've had making graphs is going to play into this. Like, it seems that this has labels. So it's going to have an X label and a Y label command. There's going to be a grid on command because this has the grid. There's going to be a title command. So, the graphing part will be at the end of the script, but inside of the script, let me write down a couple of the components that you're going to have to use. The command Linspace you will have your time variable. You're going to need to use the Linspace time variable. What I'd suggest is that we want to go from 0 to 30 as like our time range, but do 100 pieces of that. And the Linspace syntax is your first number, then your last number, and then you have in the third term of Linspace the number of terms. And so in our case, it's going to go from 0 to 30, and 100. There should be 100 dots on our graph for time. So you're going to have to define the time variable using Linspace. Now, you're also going to have to create an empty vector for all of the values to be stored in. And so you're going to use the zeros command, where we have from 1 to 100, meaning that if you've got 100 time steps, you want to have 100 elements inside of your distance, vector. And so t is going to be time variable, x is going to be our distance variable. Okay, and then inside of our script, there's going to be both the loop and then also if-thens. And so think about how are you going to work the if-thens in this script. You're going to say if time is greater than 0 and less than 10, then this will be the calculation for x. Else, both terms have to be true, both that it is greater than 10 and greater than or equal to 10 and less than 20. And so you may remember that if there are two terms that have to be true, you can use the AND. Let me write that down. So AND works like this. Statement 1, comma, statement 2. And so the way that the AND works is that both things have to be true. And so what we're saying is that it has to be greater than 0, greater than or equal to 0, and less than 10 in order to do the first element within the if. And so if both of those are true, then it's 0.5 t squared. And so the counter is going to go from 0 to 100. And so let me pause for a moment. And what I'd suggest, like I said before, is try putting some things down on paper before you start typing. Like think about what are going to be the elements of the script, writing it in terms of pseudocode. And then I'll circulate around if you have specific questions and get stumped on any certain thing. Yeah, yeah. Mm-hmm. Yeah. No, less than. There we go. So hopefully with this, you're sort of getting an idea of what the pattern should look like. You can finish the else if, so that will be batch number 2. You know, there's the first batch, the second batch, and the third batch of numbers. So the first batch is within the if. The second one is inside of the else if. And then to terminate, we'll have else, will be our final command. So down here we'll have else. And then we have to do we don't have to necessarily have the AND operators though inside of the else, because any other conditions, if we are greater than 20, then it should do this last one, put in the last equation. So we don't have to have an AND operator, because it's just any other numbers are definitely automatically going to be greater than 20 but less than the 30, which is our time limit. I love it. As a reminder, what the graph should look like when we're finished is this. Nice even time versus distance. So we will pick this back up on Thursday, but as a reminder for the announcements, you don't have a homework assignment to be working on. If you didn't finish your course evaluations, you know, you can do that for your other classes as well. Hopefully you use the time to do it for our class, but I will see you Thursday.